Hello everyone and welcome to another tutorial. In this episode we're going to see how to make a wavy pattern. We will be able to control the upper curve, the radius, the height, the number of subdivisions, then the shape of the curve, among other stuff. So I hope you enjoy it. The wavy shape we are going to do it with a component called Tween curve. There's a similar component in Rhino that what it does, but for surfaces. So this one works only with curves. So what we're going to do is create the curves and then extrude them so we can have many surfaces, and with that we'll create the wavy pattern. So to create the curves, what I'm going to do is I'm going to go to the front view and I'm going to create a point and then an SDL line that comes out from that point in the X direction, and then I'm going to define its length with a slider. Let's create a slider maybe from 100 to 500. So this is going to be our first curve, and then I'm going to create another curve. I'm going to turn this off, that I'm going to be controlling with a graph mapper. So to create this curve, I'm going to go to construct point, and then I'm going to get the graph mapper. Okay, the graph mapper works with the range. It's already being offered here, and also with the we will construct a domain, we will remap the numbers. I'll explain all of this in a moment, and then the bounds, sorry. Okay, so what I'm going to do is I'm going to create a list of points that I'm going to be controlling with the graph mapper. So the graph mapper, I like using it with the remap numbers, because what the remap numbers does, it just reshapes or rescales the values of the graph mapper. The values of the graph mapper, according to my domain here, which I think is the easiest way to do it, is not touching this domain here. Okay, I'm not going to touch it at all. So the results are going to be from 0 to 1. So for instance, I'm going to go get a panel so we can see what the graph mapper does. And I'm going to connect it here. And I'm going to go get another panel. And I'm going to connect it here. And what I'm going to do is I'm just going to put these lists next to each other. So at the moment, everything that's going inside the graph mapper is the same as it's coming outside. And as soon as I'm going to right click, I'm going to go to graph types, and then I'm going to assign a type of graph, for instance, a parabola. And as soon as I do that, then my output, or what's going out of the graph mapper, then it's not the same as what's going in. What's going in is the list of the range, okay, that I can subdivide by adding changing this number, this input here. Now it's 10 as a default. I can change it with a slider, and as you can see, or what it does, it's just putting all those points from the first list that's coming out of the range, puts them on the x-axis, or the horizontal axis. Sorry, my pulse is not that good. I'm going to put all these points in this axis, And what it does, it just finds the first point in the x-axis, which is 0, okay, and then it projects that point on the graph, and what is coming out of the graph mapper will be its consequent point on the y-axis according to this graph. So for 0, I'm going to have 1. And as I start going up, as this parabola is coming downwards, then that number is going to come for 0.1, 0.64, and then it's going to be descending until it reaches 0, which will be this point right here, which is the middle point of our list. For 0.5, it corresponds 0. And then we start going up until we reach 1, okay? I'm going to delete this, and as soon as I start manipulating that graph, then I will manipulate the output of that list, okay? So that's basically what the graph mapper does. So what the remap number will do, you can see these numbers here are also from between 0 and 1, but if I want numbers or I want a range of number within different bounds, then I can scale them, scale these numbers. So that's what I'm going to do with the remap numbers. So I'm going to delete this, and then I'm going to delete this. And what we do is just connect the values for that we want to remap, and we need to know the bounds, the highest and the lowest number of that list. This is what the bound gives us. And then we have the target domain, which is this one. Okay, as a default, we know that the domain comes from 0 to 1. If we leave it as it is, then we wouldn't be doing anything. But as soon as we start putting numbers in it, then we will be doing something else. These numbers, or the numbers that I want to remap, are the ones that I'm going to be connecting to the z direction of this list of points. Okay, and then on the x direction, I'm going to put a range. Okay, right there. Okay, so the next thing that we need to do is define the values that we want that list of points to be going through. So the biggest number that I want to reach on the x-axis is going to be the same as this length. So what I'm going to do is I'm going to connect this length on this domain. So it will automatically construct a domain from 0 to that number. Okay. The other number, the other thing that we are going to control is the amount of points on that curve. I'm not going to touch it yet, but it has to be, this amount has to be the same as this one right here. The other thing that we're going to control is how much we want, or the variation of those points on the z-axis, okay, which is what we did on the remap numbers. So what I'm going to do is I'm going to create a slider that it will go from, let's say, I don't know, 20 to 50, and I'm going to copy and paste it. Okay, and then what I'm going to do is, actually for the moment, I'm going to leave this disconnected. And I'm going to exaggerate this, and as you can see, if I change this graph, I'm going to actually get a different one, for instance, the sine function, and you can see this, that as I move it, the position of those points is going to change because all the process that we did previously. So what do I want these points for? To create a curve. So what I'm going to do is I'm going to get the interpolate component, and if I turn this off, I'll have my other curve that I will be connecting to the tween curve. Okay, so the next thing that I need to do is move it higher up on the z-axis. So what I could do is add, or maybe, yeah, add a plus here, and connect this here, and then a number for that will determine the height of this curve. Let's make a slider out of 500, and I'm going to connect it here. 500 might be too much, and there we go. And that will help us, or yeah, we will be able to move it up and down without changing the shape of the curve. Okay, we could also do all of these curves, I mean both of these curves in Rhino. It would be definitely easier. It wouldn't be parametric, but also I wanted to explain how the graph mapper with the remap numbers works, because I believe they're both very useful. Okay, so now that we have our curves, I'm gonna bring this here, and I'm gonna make a couple of groups out of them. So we have a more organized algorithm. This is one curve, and this is the other curve. And then I'm going to connect one curve to the input A and the other curve to the input B. Before we go on, I'm going to create a slider to make sure that if we change the amount of points on those on these ranges, I mean in one of those lists, they will go together. Okay, that way yeah, it's parameterized. I could leave it as it is, but I'm gonna put it. Okay, and then right here, well, the other input that we have is how much we want that twin factor to look like, to the curve A or to curve B, and where we would want it to be. But what we're gonna do is we're gonna create a list of curves. So I'm gonna get a range, and you can see that if we put our mouse on it, we need numbers within 0 and 1, which is what the range gives us. So I'm going to connect this right here, and now we have that amount of curves. And if I create a slider to control the length of that list, let's create a slider from 10 to 50, for instance. Then we can change the amount of curves. The amount of those curves is going to determine the amount of waves, or the waves our shape is going to have. So the other thing that I will do before we go on is make sure that this number is even. Okay, that way it'll have more sense. So I'm gonna put this on even, and there we go. We can turn this off and turn this off, and so far we have done everything in Grasshopper. The next thing that we're going to do is we're going to extrude them. Okay, so we are going to make surfaces out of those curves on the y-axis direction. So I'm going to go to extrude, on the y direction. And how much do I want to extrude them? Let's create a slider, or what we can do to have square surfaces. Let's connect this one here. Okay, or square surfaces on the projection of the x and y axis. Okay, now that we have those curves, what I will do is create a cylinder, okay, and then check where the intersection of those surfaces are with the cylinder. So I'm going to find the center of the bottom surface, which is flat, with the area component. I'm going to find the bottom center, which is going to be here. So I'm going to go get a list item. And it's giving me the first one. Sorry, the first curve. I need to connect it here. Now I have the first surface. So it's giving me the highest one. I need the bottom one. So what I'll do, it's going to be the last one from our list. So what I'll do is I'm just going to I can do many things. I can reverse this list. Okay, I'm gonna go here and reverse it, and then my first element of that list is gonna be the lowest one. So that's one way to do it. The other thing that I could do is if I put here, if I don't reverse it, but I want my item, sorry, my -1 item, I'm gonna go to -1, for example, with a slider, it's gonna give me always the last item of that list. That's another option, okay? So what we wanted is connect this here, and that way I'll have this center of the bottom list. Sorry, of the bottom surface. That way, why do I want the center? Because now I can create a circle with the on the center of this one. I'm going to turn this off so we can see it. And the radius of that circle has to be, so I always have an intersection lower than this length right here. Okay, so it has always to be lower than this one right here. So what I'll do is just gonna make a comparison or a boolean out of it. So how do we do that? To make sure that that number is always smaller than whichever number that we put on the radius, we are gonna use a component called minimum. What it does, it just compares two numbers and gives us the lesser or the smaller number. So I'm going to connect this one, and then I'm going to connect another slider that goes, this is going to be the radius, so it has to be divided by that one, sorry, divided by 2. And then I'm gonna get another slider that goes from 50 to 500, for instance. Okay, and then I'm gonna connect it here. So if I make this number bigger, it will reach the size of that square. But I don't want that. I want it to be even slightly smaller than that. Otherwise, I might have trouble with the intersection. So what I'm going to do is I'm going to create a subtraction, and I don't know, let's put a number like -5, and then I'm always going to be subtracting 5 out of that number. That way, if I make it the same size, it's always going to be within, it's not going to reach the boundaries, and that way I'll make sure that I don't have any trouble with the intersection. I'm going to turn this off, I'm going to turn this off, and then we said that we were going to extrude this curve on the z-axis to find the intersection with the other surfaces that we created. So I want to extrude this on the z-axis. And how much do I want to extrude it? Well, I need it to be always higher than the highest surface. Okay, even higher than that. So I can make sure that I will always have an intersection. Okay, so where do we get that number from? We will get it from this number right here. Okay, this is the highest number of the I can get the highest number here and then add something to it. So what I'll do is I'm going to get a sort list component, and this is the list that this is just going to sort that list of numbers, which is already sorted actually, but no, actually it's not sorted. I'm going to make sure it's sorted, and I'm going to reverse it. Okay, the output, I'm going to reverse it, and then if I get a list item, the first number of that list is always going to be the higher one, and if I get a list item, then I'm going to be always getting the highest item of that list. Okay, and if I still want to make sure that my extrusion is even higher than that, okay, I'm gonna make a plus, let's say for instance 10. So I'm adding 10 units to that number, and that way it's always going to be above it, okay, no matter what values I put. I'm parameterizing it, so if I change anything, it won't give me any trouble. The next thing that we're going to do is just organize this a little bit. We know that we want the intersection with this and with this. So what I'll do is just create, let's say, we know that all of this, actually this way, is the progress we did to create the cylinder, the parametric cylinder, and then right here we have the other extrusions. Actually, I'm going to join it as well with the tween curves. Let's do it like this. Okay, now we are going to find that intersection that we're looking for between those curves. So the intersection, we're going to do it with the rep component, and this is going to be one brep, and the other one is going to be this one right here. Then I'm going to turn this off. And this one as well. Also, I'm going to turn this off. Oh, which doesn't matter because it was taking a number. And then we have those curves. The next thing that we will do is scale them. So we need to scale some of them towards the middle, or we could make them bigger, but we want to scale one, we will scale it, the other one we will leave it as it is. We'll scale one, then we will leave it as it is, and so on. So I'm gonna go get this scale component non-uniform, okay, because I'm only gonna scale on the X and Y axis. Okay, so before we scale, we need to separate one curve with the next one curve with the next one, and so on. To do that, we're going to use the dispatch component. The dispatch component, it will just split or dispatch a list of numbers or a list of things with a default pattern that I can modify. That pattern, the default pattern, is true false. So that's exactly what we need. So one's going to go to A, one's going to go to B, one's going to go to A, one, and so on. If we wanted something else, then we would modify. We're going to leave it as it is. So I'm going to connect this here. I'm going to turn this off. And as you can see, we have a tree coming out of this component. So I'm going to flatten it so we can make it a list. And if we get a curve param, you will see that we will be selecting one curve but not the others. So one of the curves are in A and the other curves are in B. Okay, so now I'm going to scale some of them. Okay, the geometry that I want to scale is going to be this one, the B, the A, I'm going to leave them as it is. And the plane of scale, okay, what we are going to do is we're going to create another SDL line, a vertical SDL line that goes from the center point of the lowest line. Sorry, this is going to be the start line. The direction is going to be in Z. We're just going to make a vertical line. And then we're going to make another intersection to find the center point or the approximate center point of those surfaces with this line. Then the length of that line is going to be the same. Let's put the same as this extrusion right here. So I'm going to just go here and here. There we have our line. And to find that intersection, I'm going to go get another component that is surface curve component. So the surface curve component is just going to give us the intersection between surfaces and curves. So I'm going to connect the curves here and then the surfaces right here. Okay, now that we have this, we also need to dispatch it, okay, because we are not going to be scaling all of them. So I'm going to go to dispatch as well. We also have a tree coming out of it. I'm going to flatten this. Sorry, actually, what's coming out from C is not what we need. We need what's coming out from P, which are the points. And then I'm going to flatten it. And the ones that we need are the ones coming from B. Okay, that's going to be the plane of scale of our curves. I'm going to start turning things off. And let's make that scale. We want that scale to be in the X and Y axis. So I'm going to go to create a slider from 0.50 to 1, for instance. And then I'm going to connect it to X and Y. And I'm going to make it slightly bigger. Okay, and now that we have both groups of curves, we need to make a loft. Okay, the thing is that if we make a loft like as it is, so if I connect a list of or a group of curves, it's just gonna create a loft in between all of them. But I don't want that. I want it to go for, to grab an item from one list and then the other one, so we can have that wavy pattern. To do that, there's a component called Weave. Okay, and this does exactly the opposite as the dispatch. What this does, it just grabs an item from one list and grabs an item from another, depending on the pattern that we give it. Now it is grabbing one from 0 and one from 1. This is input 0 and this is input 1. And that's exactly what we need. So if I connect it here, then we have that wavy pattern that we were looking for. Okay. Turn this off. Okay, and now we have exactly what we were looking for. We can go to the loft options and change, for instance, the alignment or the development of that surface, depending on what we are looking for. Okay, and we can of course always go back and change the starting curve. Sorry, yeah, that curve from the beginning of our algorithm. We can change the height, we can change the radius. We could actually create a different kind of surface on Rhino, okay, and put it here instead of the cylinder. And if we did that, then we will have just a different shape. Okay, so if we wanted to thicken it, okay, or what we could do is take it to Rhino to put a flat surface right here, and then we could thicken it with the Weaver Bird component. Here with the offset, sorry. We will need to make it a mesh first. And then we can offset it. This is a very useful plugin, Weaverbird, for especially working with the meshes and that kind of stuff. I'm gonna make it less thick, and actually I'm gonna soften this. I'm just gonna leave it as normal. And then you can change the distance of the offset and so on. Okay, so I hope you liked it, and I'm looking forward to read your comments or questions. Thanks for watching.